Hi, this is section 12.4, linearity over groups. So the testing linearity. So think about the case that the discrete ordered variable x, so such as the survey rating and maybe the count data. So that is primarily the categorical variables, but it's ordered. So occasionally it can be just regarded as the continuous variable for regression purpose. Yeah, movie rating, maybe, the rating of 10 does not necessarily mean twice as big as 5, so it doesn't make much sense. But in some cases, such as count, for example, the number of children, then it makes sense to make it as a continuous, to regard it as a continuous variable. But if, for example, think about the expense of a household by the number of children, then if children increases, then a marginal increase in expense is probably going down. So the relationship between the number of children and the expense isn't necessarily linear. So it really depends on the case. So we want to test if the relationship between x and y is linear or not. So if we regard x as continuous variable, we only use one parameter. So the beta times x, so maybe beta 1 times x, so one parameter. But if we regard it as categorical, then we have p minus 1 parameters if we have p categories. So basically, we have one baseline. Baseline is basically absorbed by the intercept. Then if we have p groups, p categories, then we have the indicator variable of x is second one, maybe I would say beta 2, plus beta 3 times indicator variable of the third category up to indicator variable for p's category. So we have p minus 1 parameters. So we don't have x is equal to 1 because the baseline is included in the intercept. So we need a lot more parameters. So it's the negative side. Yeah, so continuous is better to save the number of parameters, but we have assumed linearity, so it's less flexible. So we have a trade-off between these. So think about these two models. So we want to see the price of a house, and the predictors are square footage and year. So these are linear predictors, but the number of bedrooms. So this isn't necessarily a continuous variable. So sometimes, probably the 2-bedroom apartment is more expensive than 1-bedroom apartment, but if bedroom is 6 or 7, probably that does not really matter. So we think about, okay, so still we include the number of bed here, but we also include the indicator variable here. Then we see if this is significant or not. Yeah. And okay, so yeah, so here the beta for I, but the I represents the factor for I bedrooms. So I is equal to 2, 3, 4, 5, 6. And actually in this database, it's a little bit strange, and there are no houses with 1 bedroom. So the number of bedroom is either 0 or 2, 3, 4, 5, 6. So we need the indicator function, 2, 3 indicator functions for the bedroom is equal to 2, 3, 4, 5, 6. So we have 5 variables. Yeah, but actually, if we don't have continuous variable beta for bed, then we need the 5 levels, but we have already used one parameter here. So actually, this one that we only use the 4 parameters. So we have 4 parameter here, and here is 1 parameter. Yeah, then this is the code. So the price on these 4 variables, and then we also make bedroom, the number of bedrooms as factor. Then we fit this, and we added this, the bed f, so factor. We compare this model 3 with 4. Yeah. Maybe I would say that this is 4 versus 5. So some trouble about the name of the equations. And yeah, so at first we think about the result for the equation 4. So this is continuous variables, and all are significant, and so on. And the p-value for the number of bedrooms is 0.004548. So at least we should include the bedroom as continuous variable. We should give at least 1 parameter for bed. How about factor variable? Okay, so the baseline is the 0 bedroom. Then the factor for 2 bedrooms, 3 bedroom, 4 bedroom, and 5 bedroom. And this is redundant. If we don't have this bed, then we can have numbers here. But since we have already used 1 parameter and we only need the 4 parameters, actually this is not bed.f6 wasn't used. So if we omit the number of bed in the parentheses, we omit that variable, then the bed f6 has also the coefficients. But the one thing here we can see is that okay, so the number of bedroom as a continuous variable still is very significant, but also the difference between the baseline and the 2, 3, 4, 5 is actually the significant also. And yeah, it's a little bit strange, but the bed have the negative coefficient, but the bed 2, 3, 4, 5, these factor variable, indicator variable, have the very large positive number, and it's increasing over time. So probably if the number of bedrooms is somewhat small, then actually the price is a little lower, but yeah, it's a little bit hard to interpret, but we have nonlinear relationship between the number of bedroom and the price. And you can see that the adjusted R square is 0.8322. So these are significant, and also adjusted R square, it improves a bit, maybe 1%. And we haven't calculated AIC, but if these variables are so significant, then we can believe that the AIC is also better, smaller for the this larger model. So probably this means that if we introduce a parameter for each level of bed, that is good. Many of them are significant predictor for price. And if we make this ANOVA table, so this is sequential test. So basically this can test if this original model and the model with additional variable is better or not. So actually, if we add additional variable, then okay, we have even 4 parameters. Still, the f value is really the small. Sorry, the p-value for this f statistic is very small. So this is a significant factor. So even if we have the first 4 variables, we should add the bedroom as factor. So if we include both, actually, we can eliminate this, and you can just prepare 5 parameters for this factor variable. So that model is better than the bed as continuous. Yeah, and AIC, finally, we can see that the AIC, actually, the bit larger model is better by 18. So it's much better. So AIC gets worse by 2 if variable is entirely useless. So the improvement of 18 is pretty large amount. You can do the analysis for the number of bathrooms also. Yeah, so in reality, the number of bathroom actually matters a lot to property price because the bathroom is more expensive and adds value for houses.